In this video, let us solve 3 questions from mechanics which were asked in JEST 2022. So the first question is to find the force acting on a system. We are given the relationship between dynamical variables. Here x0 is initial position, k is also a constant. So to get the force is ma, mass times acceleration, which is equal to m times x double dot. Here x double dot represents second derivative with respect to time of position. From the relation given, x dot square is equal to k x naught square plus x naught dot square minus kx square. We have to somehow get x double dot. Therefore, we will take derivative with respect to time. If we differentiate with respect to time, we get 2x dot x double dot is equal to k is constant, x naught is constant. So their derivative is 0. X naught dot square is also constant. Its derivative is also 0. Minus 2kx x dot. Now 2 gets cancelled. X dot gets cancelled. This implies x double dot is equal to minus kx. Now f is equal to m x double dot is equal to m times minus kx. Now it is given that the mass is unit mass, therefore m is equal to 1. M is equal to 1. This implies f is equal to minus kx. Therefore the correct option here is option A. Let us move on to the next problem. Here we are given centripetal acceleration to be equal to k square r t square. We have a particle of mass m. It is moving in circular path. Radius of the circle is small r and its centripetal acceleration is varying with the time. It is given AC is equal to k square r t square. Now centripetal acceleration is also given by v square by r. Therefore we have v square by r is equal to k square r t square, which means v square is equal to k square r square t square, which implies v is equal to krt. This is the tangential velocity. There are two forces acting on a particle which is moving in a circle. So this is the particle that we have. There are two forces on it. One is centripetal force, which is directed towards the center and it is responsible to keep the motion of the particle in circular path. Another force which acts on the particle is tangential to its path and it is responsible for the change of speed. Now tangential force is equal to m times dv by dt. V is tangential velocity. This is equal to m times d by dt of v is krt. This is equal to mkr. So this is the tangential force. Now power is equal to F dot V. This is equal to tangential force plus radial force, radial or centripetal force, both are same. Centripetal force is the force which is responsible to keep the particle in circular path, or we can say it is responsible to change the direction of velocity, and tangential force is responsible for the change in speed. This is dotted with velocity. Now velocity of the particle is always tangential to the path, so velocity is also along f of t. Therefore Therefore ft dot v is equal to simply fv. Because ft dot v is ftv cos theta, theta is the angle between ft and v, and the angle between ft and v is 0 degree, which means cos 0 degree is equal to 1. Therefore ft dot v is simply fv. And fc dot v, centripetal force dot v, this is equal to 0 because fc and v are perpendicular, and dot product of perpendicular vectors is equal to 0. Therefore we have P is equal to ftv, which is equal to ft is mkr, we found it here, mkr times v is krt. Therefore we have m k square r square t. This is the power delivered. Now there is another approach to do this problem. You can find E, energy, it is equal to kinetic energy plus potential energy. If we assume potential energy to be 0, then this is equal to half mv square, and v is krt. Therefore v square is k square r square t square. And then we can find power using the relation P is equal to dE by dt, which is equal to m k square r square t. Let's see how we can do the third problem. Here we have a train. The train is moving with the constant acceleration, and it passes a pole with the velocity u. So the initial velocity is u. Its back end passes the pole with the velocity v. So the final velocity is v. With what velocity does the midpoint of the train pass the same pole? So the situation is like this. This is our train. This is the pole. The front end of the train passes with velocity u. Now the back end of the train, it passes with, so train is moving with a constant acceleration. The back end passes with velocity v. So the velocity of the train when its back end is passing is v. Now we are asked to find the velocity of the train when the midpoint of the train is passing the pole. So to solve this question, we can make use of constant acceleration formula. When there is constant acceleration, there are formulas like v square is equal to u square plus 2as. This is one formula. Another formula is v is equal to u plus at. We also have s is equal to ut plus half at square. In this case, we can use v square is equal to u square plus 2as. So the final velocity, initial velocity is u, final velocity is v. So let's find the acceleration. A is equal to v square minus u square divided by 2s. This is equal to v square minus u square divided by 2 times s is the length of the train, which is L. Now let us find v prime. V prime is the velocity with which the midpoint of the train is passing the pole. V prime is equal to, again we can use the same formula, v prime square is equal to u square plus 2as. This is equal to u square plus 2 times, we found the acceleration to be equal to v square minus u square divided by 2L. And s is, now the distance is L by 2. This implies v prime square is equal to u square plus this 2 and this 2 gets cancelled, this L and L gets cancelled, u square plus v square minus u square by 2. This implies v prime square is equal to 2u square plus v square minus u square divided by 2. this is equal to u square plus v square by 2, or v prime is equal to u square plus v square by 2 under root. So the correct option here is option A.